Hi everyone, today we're going to be going over the instrument ACS. We're going to be starting with Area of Operation 1, Task Alpha, which is pilot qualifications. The objective of this task is to determine the applicant exhibits satisfactory knowledge, risk management, and skills associated with the requirements to act as PIC under instrument flight rules. For the knowledge portion, the applicant must be able to demonstrate understanding of certification requirements, recency of experience, record keeping, privileges and limitations, Part 68 Basic Med Privileges and Limitations. Starting with Kilo 1. So, your instrument rating is required when you're an IMC on an IFR flight plan in Class Alpha. The conditions are less than VFR conditions or special VFR nighttime in controlled airspace. In the previous 6 months, you have had to done 6 approaches, holding, tracking, and intercepting in order to remain current to file IFR. You must do all parts of the approach to count towards your 6 approaches. That means if you're in IMC conditions and you're trying to log your one of those approaches towards your 6 hits, you have to do it all the way to the final approach fix for it to count. And all of that must be done in IMC. You can break out after your final approach fix and have it count, but if you break out prior to that, it cannot count. You can do this in an approved simulator in the plane or with a view limiting device such as foggles or a hood. If your 6 months expire, you have a grace period of 6 months. In those 6 months, you have to accomplish the same 6 approaches, including holding, tracking, and intercepting. If not, you have to go for an instrument proficiency check. This IPC must be done by a CFI, DPE, or approved FAA person. And don't forget, you still have your same currency requirements as private pilot. So that's to carry passengers, you need 3 takeoffs and landings in the previous 90 days. Your night landings must be to a full stop. Make sure you're logging all of these things in your logbook so you can prove that you are current to file IFR or to take passengers or anything. And make sure you're also logging the name of your safety pilot in the remarks section. You don't have to log their whole number and everything, but just in case your logbook ever gets audited, make sure you have a way of reaching out to the safety pilot so they can say, yes, I did fly with this person. And make sure you're only logging the time for actual or simulated conditions when you're actually only flying based on the instruments. So that means if you are taxiing, you cannot count that towards your simulated or actual at all because you're still able to look outside and taxi. Moving on to Kilo 2, privileges and limitations. You have the same things as private pilot. You cannot carry passengers for hire, pro rata share only. You can fly your friends and family. And now you get to fly in Class Alpha and under IMC conditions. Now for Kilo 3, Part 68 Basic Med Privileges and Limitations. You can fly under IMC with the normal restrictions like no Class Alpha, you have to have less than 6,000 takeoff weight and no more than 6 seats in your aircraft. And you have to make sure you're doing your medical evaluation course with your state certified physician and everything in order to be current. Now, moving on to the risk management portion, the applicant is able to identify, assess, and mitigate risk associated with proficiency versus currency, personal minimums, fitness for flight, and physiological factors that might affect the pilot's ability to fly under instrument conditions, flying unfamiliar aircraft, or operating with unfamiliar flight display systems and avionics. So Romeo 1 is proficiency versus currency. Current means you are legal to fly, you have all of the things on the checklist checked off. Proficient means that you are skilled to fly to a good level and you feel safe flying and you are safe flying, not just crossing off the checklist. Now moving on to Romeo 2, personal minimums. This is a huge thing that your DPE is 100% going to ask you about. Personal minimums change for everyone. There's no such thing as like bad personal minimums or anything. It's just whatever you feel comfortable with and would go fly in real time with. So the best way to just demonstrate that you have set personal minimums is Download the AOPA sheet for personal minimums, print it off, look over it, give yourself like enough time to do it. Don't feel rushed doing it. And get it looked over by your CFI and have them sign it. And then every couple of months, when you feel like you can go more and more and change your personal minimums, go ahead and look over it and change it and get it re signed by CFI. Romeo 3 is fitness for flight and physiological factors that might affect the pilot's ability to fly under instrument conditions. So, this is the same I'm safe checklist we're already used to: illness, medication, stress, alcohol, fatigue, emotion. Make sure any medications you're taking are approved by the FAA to be taking, and you can go fly within a certain amount of hours of taking it. Like I said, you can find those all on the FAA website. Your blood alcohol level has to be less than 0.04 and 8 hours bottle to throttle. And your fatigue, you have to get at least 8 hours of sleep before you go fly. Make sure that you are mentally ready to fly under IMC, because instrument flying is so much more difficult than VFR flying. There's so many different things you have to pay attention to at once. And if you're tired or just not feeling well, you're not going to be able to do good at all at flying it. And that puts you in such a dangerous position, and your passengers too. Just make sure you're fit to go fly before. Lastly, we have Romeo 4, flying unfamiliar aircraft or operating with unfamiliar flight display systems and avionics. I would not fly with different avionics and IMC for the first time, just because you already have like such a huge workload with talking to ATC, loading all your approaches, doing so many different things at once, that you don't want to add different avionics you've never flown before and have no idea how to use in that whole mix. It'd be better to go fly it in VFR, or bring a pilot who is familiar with this system, with the whole plane and everything, just so you make sure that you are comfortable flying the plane and that you not knowing how to work the avionics won't cause an issue in the flight. Now we're going to move on to Area of Operation 1, Task Bravo, which is weather information. So, the objective of Task Bravo is to determine the applicant exhibits satisfactory knowledge, risk management, and skills associated with obtaining, understanding, and applying weather information for a flight under instrument flight rules. Kilo 1 is sources of weather data for flight planning purposes. So this is like all your places that you could get any weather data from. So that's like 1-800 Weather Brief, or 1-800weatherbrief.com, aviationweather.gov, flight service, ForeFlight, whatever you use to get your weather. Kilo 2 is going to be acceptable weather products and resources required for pre-flight planning, current and forecast weather for departure en route and arrival phases of flight, such as Alpha is airport observations, METARs and species, pilot observations like PIREPs. So METARs are meteorological aerodrome reports that show the current observations at a specific airport. Species are just more punctual METARs, so they get sent out in 10 minutes following an improvement in weather conditions. Now let's talk about PIREPs. So PIREPs are pilot reports. To make one, you call flight service station and use the script in the back of the green chart supplement. And there's two different kinds of PIREPs. You have your uniform alpha and just uniform alpha. Uniform alpha is urgent ones, and uniform alpha are just the other ones. Bravo is surface analysis charts, ceiling and visibility charts. Just make sure you know how to locate and read and decode all of these different charts, and you'll be fine. Charlie is terminal aerodrome forecast, so that's your TAFs. Those are useful within 5 nautical miles of an airport, and it has times that it is valid for. After this, we have Delta, which is graphical forecast for aviation, your GFAs. So just make sure you look over all of them, all of the different charts, and make sure you know how to decode them. And if you can't figure out like what certain symbol means, make sure you know where to go to find out what each symbol means. Echo is the winds aloft. So if it starts with a 7, the number, make sure you do minus 50 plus 100. You probably should know what this is from private. If your temperature is missing, your field elevation is within 2,500 feet of the altitude. And if everything is missing, field elevation is within 1,500 feet of altitude. Foxtrot is convective outlook, so that's just an outlook for possible weather advisory for any convective activity. Golf is a big one. So this is in-flight weather advisories, including airmets, sigmets, and convective sigmets. So let's start with airmets. Airmets are valid for 6 hours. There's three different kinds: Sierra, Tango, and Zulu. Sierra is for instrument conditions. Tango is for light to moderate turbulence. Zulu is for light to moderate icing. Sigmets are valid for 4 hours. It's for moderate to strong turbulence, moderate to strong icing, any volcanic ash or sandstorm, reducing visibility to less than 3 statute miles. And then we have the convective sigmet, which is the most severe one. So it's valid for 2 hours. It could be for embedded thunderstorms, a squall line, thunderstorm covering more than 40% of the area, surface winds greater than 50 knots, hail greater than 3/4 of an inch in diameter, or a tornado. A squall line is just a huge line of thunderstorms that's in a line. Now let's move on to Kilo 3. Kilo 3 is meteorology applicable to departure en route, alternate, and destination for flights conducted under IFR to include expected climate and hazardous conditions such as alpha is atmospheric composition and stability. We have two different kinds of stabilities: static stability and initial, which is the initial tendency of the plane to return to level flight. So we have three different kinds: negative, neutral, and positive. So imagine you're just flying straight and level, and for some reason, your hand pulls the plane up a little bit. And now you're going up, but you don't realize it because you are too busy doing something else. So, what is the plane going to do? If it keeps steepening that amount of pitch that you're holding, that the plane is holding itself, that means it's negative. So, it's getting worse. If it's staying neutral, that means it's just the same pitch and it's not changing. If it's positive, it means the pitch over time will go back to level. Dynamic stability is a tendency of flight to return to level over time. So imagine this as you are going up and down a little bit by accident, and plane is doing it itself. If it's negative, it's going to keep getting worse and worse, so you're going to go up and down higher. And if it's neutral, it's just going to stay the same the whole time. If it's positive, it's slowly going to start going back to level. In order to have dynamic stability, we need positive static stability. Now, about this atmospheric stability. So, atmospheric stability is the atmosphere's ability to resist vertical motion. So, if your air is stable, that means there is like a less than 2 degrees Celsius per 1,000 feet change. If that change is greater than 2 degrees per Celsius per 1,000 feet, that means it's unstable. The standard atmospheric pressure in millibars is 1013.2. Bravo is wind. So here we can talk about a few different things. So the first thing is wind shear. So wind shear is the sudden change in wind direction and speed, and this is super dangerous, especially during landings or takeoffs, because if a headwind turns into a tailwind, it could happen in seconds, and that's super dangerous, as we know. There's mountain wave, which is also known as mountain wave turbulence. So, this is the atmospheric wave disturbance caused by stable air flowing over mountains, which disrupts the flow. So, you end up getting all this turbulence. Now, we'll talk about some factors affecting the wind. So, you have three different factors: the pressure gradient force, PGF, you have the Coriolis force, and friction. So, the PGF causes the wind because high pressure always wants to move to low pressure. So that means that wherever there's more high pressure, it's going to move towards the low pressure, which is that's exactly what's causing the wind. You have your Coriolis force, which is a force that is at a right angle to the wind direction and is directly proportional to the wind. So that means if your wind is increasing, this Coriolis force is also increasing. It deflects air to the right in the northern hemisphere and to the left in the south. And the last thing is friction. Friction between the wind and the surface of the earth slows down the wind. So, Charlie is temperature and heat exchange. So, this is due to the consequence of the temperature being different. This is also known as convection. Delta is going to be moisture or precipitation. So, this happens when tiny condensation particles go through collision and coalescence. Collisions occur when the small droplets are falling down and they're all colliding into each other. And as they're falling, they stick together and become larger, which is coalescence. Echo is weather system formation, including air masses and fronts. So, an air mass is a large body of air with uniform texture all throughout. So, you'll have the same winds, temperatures, and other properties that are the same all throughout this air mass. Fronts are the transition between air masses. They're the transitions or the boundaries between air masses. You have four different kinds of fronts: cold, warm, stationary, and occluded. Cold is represented by a blue line with blue triangles on one side. So, cold, you'll have bad weather, it'll be unstable air, you'll have good visibility because all this unstable air, and you'll have cumulus clouds. For warm fronts, you'll have better weather, it'll be stable air, but bad visibility, and you'll see stratus clouds. Stationary fronts happen when cold and warm fronts come together and hang out for a bit. So they have a mix of the cold and warm properties, but it'll always have showery precipitation for long periods of time. This one is represented by circles, half circles on one side, and triangles on the other side of the line. And it's both red and blue. Now moving on to occluded fronts. Occluded fronts has the worst weather. This is when thunderstorms happen. There's good visibility because the air is unstable. And this is the front that is shown by the purple triangle and half circles. Now we're going to talk about clouds. So we have four different types of clouds. So one of them is going to be cirriform clouds, which are the high level clouds. They form above 20,000. They're made up of mostly ice crystals and they're thin, wispy, and light. The nimbus clouds mean rain. They form between 7,000 and 15,000, and as they thicken and the rain starts to fall, they're going to come to lower altitudes and reach the ground more. Next, we have cumuliform clouds. These are the white, fluffy clouds that look like cotton balls. They show the vertical motion in the atmosphere, and if it's more humid outside, it means we're going to have lower cloud bases. Next is stratiform. So stratiform clouds are the clouds that cover the whole sky. So it'll make it look super dull. We'll have like gray looking weather. And that's it for stratiform. Gulf is turbulence. We have a few different kinds of turbulence reasons. We have convective currents, wind shear, and mechanical. So convective is every rising current has a subsequent downwind, downwards current. And it's most prevalent in the afternoon. That's why usually when you go flying in the afternoon, it's always super bumpy. And then we have wind shear. We already talked about wind shear. Mechanical is the mountain wave turbulence, the wake turbulence, or any other obstructions that can cause turbulence. Next is hotel, which is thunderstorms and microbursts. So you have three ingredients for a thunderstorm: unstable air, a lifting force, and moisture. Only if you have those three things will we see thunderstorms. They also have three different stages: cumulus, mature, and dissipating. Cumulus is mainly updrafts and it's kind of like the calm before a storm period. Mature is as soon as the precipitation hits the surface. And dissipating is mainly downdrafts and microbursts when the storm starts coming to an end. A microburst is nothing but an extreme downdraft up to 6,000 feet per minute. India is icing and freezing level information. So we have three different kinds of icing. We have structural, instrument, and induction. Structural icing is either clear, rime, or mixed. So clear means that you can't detect it or anything. Rhyme means that you probably could like see it kind of if you paid a lot of close attention, and it's gonna put like these bigger pieces of ice everywhere. Clear is just like a flat surface, and mixed is both clear and rhyme together. The most dangerous one is clear because you cannot detect it, so that puts you in a huge danger. So instrument is like icing on a pitot tube or like your static port. It just messes up with your instruments because it'll cause incorrect readings. Next is induction. That's like if you get icing on your air filters or your carburetor or something. So freezing temperatures and visible moisture are the two things you need for icing. And this always happens whenever it reaches 0 degrees Celsius. Juliet is fog. So we have four different kinds of fog: radiation, steam, upslope, and advection. Radiation fog happens on a calm, cool night when the temperature hits the dew point and fog forms. So whenever the temperature hits the dew point, the fog is always going to form then. So for radiation fog, just remember calm, cool night. Steam. So this is when the cold air blows over warm water and the temperature hits the dew point, again causing fog. So think of this one as like it's really cold outside and you take like your hot coffee or hot chocolate or something outside, and it's just gonna put like these bubbles and everything around the outside. So next we have upslope fog. This is when stable air goes up a mountain. It goes upslope a mountain. That's how you can remember this one. It goes upslope a mountain with a little wind around 15, less than 15 knots. And the temperature hits the dew point then and fog forms. So for this one, just remember it's going to float upslope a mountain with a little bit of wind, 15 knots of wind, and it hits the dew point then and fog. Advection is when warm air over warm water flows over to cold air over land, and then the temperature hits the dew point and fog forms. For this one, we also need less than 15 knots of wind. Frost is pretty simple. Frost is kind of like ice, but it's formed by deposition. Lima is obstructions to visibility, so it's things like smoke, haze, volcanic ash, those can all reduce your visibility. Kilo 4. So this is flight deck instrument displays of digital weather and aeronautical information. So this is like if maybe you're flying like a nice new Garmin and it shows you like the VFR charts on your screen, or like if it shows the winds or something. So you have to know the capabilities of your plane and what you can see on the instruments. So Romeo 1 is making the go or no go decision to continue or divert decisions, including circumstances that would make a diversion prudent, which is like any bad weather getting in the way or not enough fuel to make it, or any passenger just not feeling well, or if there's any problem in the plane. Personal weather minimums, like if the clouds just descend more for some reason by the time you get there, refer back to your personal minimums checklist and make sure it's within. If not, divert somewhere else. Any hazardous weather conditions, like including known or forecast icing or turbulence in your winds aloft or something. And depending on your aircraft capability and your comfort, you should either make that go or no go decision. Romeo 2 is the uses and limitations of installed onboard weather equipment. Like onboard weather equipment will always have limited capabilities, and you should just call it Flight Service Center for weather briefing. You need to be careful that for things like sometimes like you might get hail far away from clouds. Any aviation weather reports and forecasts. So you need to check for PIREPs and make sure you're going through all your weather before flight, and you need to make sure that like forecasts are not always accurate. So you want to, if it says the clouds are at like 50 feet above your minimums, that's totally fine if you want to go with that, but just always keep in track that like the clouds might not be exactly at that exact level that's forecasted. So make sure to take those kinds of things into consideration. And the weather might change from the last recorded like METAR or TAF or anything. Because as we know, the forecasts are not always correct. And if you have a METAR that was recorded like maybe 50 minutes ago and they're working on recording a new one right now and you still have the old weather, that might potentially put you in a really dangerous situation. And then, of course, you always have in flight weather resources like Flight Service Station, any nearby airport weather recordings. If you ever need to like just find the winds or what the clouds are doing, what they're at, you could always listen into those. We're going to be
So now
starting
we
with
are at
Area
the
of
last
Operation
task
1,
for
Task
today's video,
Alpha,
which is
which is
Task
pilot
Charlie, cross-country
qualifications.
flight planning.
We're going to be starting with
So
Area of
the objective of
Operation
this one
1,
is
Task Alpha,
to
which is pilot qualifications.
determine the applicant exhibits satisfactory knowledge, risk management, and skills associated with planning an IFR cross-country and filing an IFR flight plan. So for this portion of this, you're definitely going to have to create a cross-country flight plan. Um, they'll tell you beforehand where to make it to usually, but yeah. So these are things you check like more than 6 hours before departure. So like the day before your check ride, maybe you're looking for all of these, any NOTAMs, runway closures, air traffic delays, TFRs, en route and destination forecasts, and your alternate if you really need it. Any synopsis, like where your fronts are, what's happening, the air masses and everything. Any weather advisories, SIGMETs, airmets, convective SIGMETs, CWAs, anything, any of those. After that, you're going to look for your standard briefing elements. So when you're actually getting your weather briefing, you're looking for these things: adverse conditions, any frontal zones, low level wind shear, thunderstorms, icing, turbulence, weather advisories, all of those things. You're looking for those. Synopsis, current weather, en route, destination, and alternate forecasts, winds aloft, NOTAMs, TFRs, PIREPs, any of those things, ATC delays, known ATC delays. um, you're looking for when you're like 2 hours within your flight, you're gonna go take your check ride. You're in the room setting up for your check ride. Check updates to adverse conditions, any reported or forecasts along the route of flight. Check for any changes in any forecasts or meteorological data you received earlier. And then after that, you're going to check your non weather related items. So that's I'm safe, your PAVE checklist, aviates, I'm air, all of those ones. You just want to check through all of those, your personal minimums, fuel requirements, alternates, traffic delays, takeoff distances, landing distances, performance items, all of those things. Your rain check if your aircraft does not have WASP, you want to check all of those. I'm gonna go over the whole PAVE acronym once more just so everyone has it down. So now we're going to talk about the PAVE checklist. So that's pilot, aircraft, environment, external pressures, the four things you want to always check before going flying. As the pilot, you're going to go over your I'm safe checklist. We already went over this in the beginning of the video, so I'm not going to spend too much time on it. For the plane, we have Aero. So airworthiness certificate, that never expires as long as you keep up with all of the required checks. You have your registration, which expires every 7 years. There's the radio station license, but don't mention that unless you know a whole lot about it, or else they're going to ask you a lot of questions and you're not going to be able to answer those. You have operating limitations, and then your weight and balance. This is not the weight and balance you do; it's the weight and balance that the mechanics do for the plane. All the different things you need to make sure you have for your airworthiness is your annual, your your VOR check. You want to make sure you have your altimeter and static system, your 100-hour, any ADs, one-time recurring urgent. Make sure you know all the different ones, transponder, ELT. I'm not going to go too much into these because you all should already know it from private. And then, of course, there's NW craft, your NOTAMs, weather, known ATC delays, runway lengths, takeoff distances, alternates available if you need them, fuel requirements, and takeoff and landing distances. So then lastly, we have I'm air, which is impulsive, macho, anti-authority, invulnerability, and resignation. Those are all external factors that could push you to make a bad decision, or like if you have like something that you really want to get there for, like get there-itis, like you want to make sure you don't have any of those things factoring into your go or no-go decision or any decisions you make at all related to flying. And with that, we're going to end the first video for the Instrument ACS study guide. And we finished all of the area of operation 1, which is pre-flight preparation. So congratulations if you made it the whole way.